In this video, we're going to continue discussing features of C++ structures. We are going to continue discussing important roles that constructors play in the life cycle of objects created from the structure definitions. We're also going to discuss C++ references and important issues related to dynamic memory allocation. So this is our presentation, and for demonstration purposes I'm going to create a copy of the previous project. So I already have a previous project which contained the source file and project files in the project directory. So what I'm about to do is just basically right-click in my file manager and say copy. So copy this folder and right-click and say paste and make a copy of it. And I'll just rename it and just say that this is our next section, section number 8. And here we have a copy of the project under new subfolder. So this is the location that I'm going to open when I'm going to say in Visual Studio File, Open, Project. And I'll navigate directly to this location and open this solution. Open the solution file. And of course it refers to the previous name. So if we go View Solution Explorer, under Solution Explorer, we have solution name, project name, and also our source files. So let's right-click and rename the solution. Okay, so that we're not mixing it up with previous names, and rename this to be week 8. Now, if you recall, we had an example of a rectangle structure with a couple of constructors and a couple of operations that we use to change the dimensions of our rectangle and set the area. Of course, we also have a small test program in our main function that creates objects of this type, rectangle, and is trying to access its data members and operations to see how it performs at runtime. So the first thing that I'd like to do before we proceed to our presentation is actually split this project into multiple source files. In fact, I would like to keep our structure rectangle in a separate header file. So let's start with the new header file. And I tend to create my header files directly in the file manager view by simply right-clicking and saying new text document. Right, so this is just plain text file which will contain definition of our rectangle class. So let's do that, and we can just do it right here. Alternatively, you can actually do it here in the header file area. You can add new item and go through the wizard. Just make sure that if you do this, just remember to add source subfolder here, because you want to create a new header file in the same folder where the original main source file is located. Right, so if we do it through this, so we can say source, right? So we need to add the source subfolder, and if we use this wizard to add new header file through right-clicking on the header file section in our Solution Explorer, of course you need to select the header file because you want that. And here we can say rectangle. Right, so I'll just use rectangle name for this header file and create it using this wizard environment. So I click add, and you see that it inserts a special pragma directive preprocessor directive in our rectangle.h header file that we created through the wizard by right-clicking on the header files. So it's possible to do it this way. I would not prefer to do this because it further complicates the structure of the project that I don't really need. You know, I rely mostly on including header files, and having your header files listed under the header files area allows you to browse for some, you know, identifiers or names and content of the definition of your classes. I really don't like these non-portable features of the project, which are really specific to only Microsoft Windows platform using Visual Studio. So this is not my big preference, but I just showed you that it's possible. Now, Pragma once is the same thing as the header guard. So to keep this portable, and I don't want to rely on Pragma, which is Microsoft specific, I will once again go to the tab of the file. This is my header file, by the way. Right click and choose copy full path. So once I copy full path, I can paste it in as a comment, and I normally get rid of the path, just retaining the name of the header file. So here now I can type, and I'll close Solution Explorer for now. Just type if not defined, if in def, this thing that I'm about to add right here, which is uppercase rectangle underscore h included. So this is designed to be a unique but ugly name. We really don't use these names anywhere. It's only for the header guard purposes. So if not defined, then copy and paste and say define. Right? So this will be defined only once. And the third line, again, copy and paste the same line one more time. If and def requires and if. So these are all symbols or directives rather of the C++ precompiler, which will allow us to manage the inclusion of this header file properly so that it gets included only once. Now I can safely get rid of this, which I suppose may not be portable on other platforms. I'd like to keep my source C++ source files totally portable, that they will compile on any platform. And with this in mind, I just get rid of this Pragma. I don't need it here. Now, besides this top comment and the header guard things, everything else is supposed to go right in this space, right? So we're just going to use this space to place everything else in this header file. Okay, so that's the approach. All right, so let's finish this rearrangement and move the header file to the new vertical document group. And of course, my idea is to take the structure rectangle, right, that was defined earlier. So this includes basically the opening brace and the closing brace, and oftentimes when I write my code, I use the structure rectangle name like this. I copy it and I add it to the closing brace right here of the structure definition. Okay, so I know this is the ending of my structure definition. So anyway, I'll just copy all of this, press Ctrl X to cut it from here and paste this in the new header file. Okay, so I have this new header file in place. Also, when we add function definitions, starting with our constructors, let's actually adjust our comments a little bit so that we can say that these are our member variables, right? Member variables or data variables or data members. This is all the same thing. Then we have constructors. So let's just have a nice set of comments here that makes it pretty clear of everything that we have inside of our structure. And I'm not going to use member functions. Actually, I can say member functions or operations. Typically, I designate them as operations in my comments and member functions, it's a C++ name for functions that are placed inside the structure declaration like this. So we have these three parts. So structures can have data members or member variables, they can have constructors, and they can have other member functions. Of course, constructors are not really generic or general purpose operations, because we normally don't invoke constructors directly when we create our objects using the new data type. Constructors are invoked for us automatically by the code that generated by the compiler. So we really don't call constructors directly. So that's why constructors are not general purpose operations. But operations such as set dimensions and get the area of our rectangle, those are very typical types of operations that we want to be able to keep. Now let's also go back to our Solution Explorer and also keep the implementation of this definition of the rectangle in a separate implementation file. This is similar to what we did with our first introduction of the header and implementation files in our previous videos. So what we need is the new source file. So I'm just going to right click and say add source file, new item. So this will be a new item, another source file, and also notice that I'm already pointing to the source subfolder in the structure of my project, which is important. We'd like to keep all of our source files in the same subfolder, so I use src source, and here we're going to name it rectangle.cpp. Okay, so we're going to click add that. So it's an empty file, which is brand new file, and of course CPP files are placed on a list of source files. The header files should never be placed on a list of source files. So even now I can actually exclude this from the list of header files. It doesn't mean that there will be any really difference in my project. So if I want to, I can exclude it from project like this. Okay, and so the header file is still remains where it was in the directory. Now I can just simply drag and drop it here, and I'll be including this file in the implementation files. So I'm just going to move the new source file, which is empty, to the new vertical document group like this, so I can have access to all of the source files that I have so far in my project. I'm going to close Solution Explorer. I don't need this anymore. In the source file for the rectangle, of course, I need to include this header file. So we're just going to say include and use double quotes to specify the header file that we want to include. Since we took a rectangle declaration out of the main.cpp source file, of course we're also going to include it right here. So the reason we added this CPP file is that now we can take definitions of all of the functions, including constructors, out of the structure rectangle declaration and keep definitions separate. How do we do this? So basically what we're going to do is starting with constructors and ending with all of these operations like this, right? So everything besides data members, I just copy like this, right? And paste it in the implementation file rectangle.cpp, which we just added to our project. And I'm just going to, what I like to do is just press Shift key down and select, using the arrow down key, the entire text, and press Shift tab to change the indentation, right? So inside this implementation file, I really don't need much of a white space indentation in front of my source code lines. Okay, and then each name like this, name of constructors, name of each member function has to be prefixed by the name of the structure to which these things belong, like this, with the two colons operator, which is scope resolution operator. Okay, so carefully copy this, right? So copy this rectangle colon colon and place it in front of every name of operation that we're using. So not in front of void, but in front of set dimensions, right? Set dimensions full name is set dimensions, which belongs to structure name rectangle. And of course, compiler already knows what rectangle is because we're including this header file. So this tells the compiler that this is a structure. And the last thing that we're going to do here is to add it to the area as well. Okay, so we have it here as well. So area, set dimensions, and two of these constructors use the scope resolution in front of their name to specify that those things belong to the structure name named rectangle. So once I have this in place in my source file or implementation file rectangle.cpp, let's go back to rectangle.h, and here, instead of giving the bodies to these constructors and operations, we're going to get rid of them here and replace them by semicolons, right? So the full definitions of our constructors now become only declarations. So we add these semicolons at the end. Similarly, with member functions, we're going to add semicolon after the signature of the function, so it becomes just a function declaration, and remove the body like this. And similar with area, after const, add semicolon and get rid of the body. So I hope that you can agree with me that this new view, new looks of the structure named rectangle getting is much cleaner. Okay, so we have a very clear view of what are the variables stored inside of this rectangle. We have a couple of constructors that we can use with this structure. And we have a list of operations that we can use with objects that are created, the objects of this type. Now, of course, if we need to see exactly what happens in the implementation of set dimensions, we go to the implementation file, which probably has a very well recognized name, rectangle.h, rectangle.cpp, find the set dimensions definition in the implementation file, and now we can analyze what is the actual implementation doing for us. So this is a better, I think it's a much better arrangement, and in terms of future development and maintenance of our source files and the features of this application. I also would like to note that we are using string inside the rectangle structure. Therefore, this include is very likely needs to be placed here. Okay, and just one quick note that even includes that typically stay very close to the top of the file. The includes supposed to be used inside the header guard, right? So we don't place includes at the top of our file, but rather already under the header guard that we added to the header file. By the way, the sole name of the header file is that because the includes, which include header files, appear to be at the top or at the head of the source file. So now also I think we're pretty much all set. I think everything else looks very reasonable in what we have so far. So I will save everything, right? So you can save all, and then let's give it a try to build. Okay, so this builds fine, and let's run it to check that everything looks fine. So we just restructured our application, and you see that the output that we're getting is exactly the same as we had in the previous version, which used only the single file for everything to do in the main implementation file, which is probably not a very promising idea. We want a well-structured application to continue development of new features.